Okay, this is module 3. It is about probabilities. It's probably the easiest module you'll have out of the 8. Um, all of Basically all this module is different marbles or marble scenarios. The marbles all have a letter printer on them, and you have to compute the probability of drawing a single marble, one marble, or the other marble, or different sequences of marbles. Okay, so in this case, you have a jar with 939 marbles. You have the letters G, E, D, F, and A. There is no marble that has both letters printed on it, so this is an easier example. If it had both letters, it'd be a little trickier. You'd have to, um, if you were asked, for example, to compute the probability of drawing a marble with the letter G, and there were 32 marbles that had the letter G on them, and let's say 648 that had the letter G and E. So you'd have to add 648 plus 32 divided by total to find the probability of letter G, and so on and so forth. I mean, this should be, um, you should have examples of this in your notes. Anyhow, so in this case I have um, 939 marbles, the letters G, E, D, F, and A. So I'm just going to create a table here in Excel. It's G, D, F, and, it's G, E, D, F, and A. Okay. Frequency is 32 marbles with G, 648 for E, 122 for D, 89 for F, and 48 for A. And the total number of marbles is 939. Okay, so Excel, what it's done is computed the probability of getting each marble for me. So for marble G, what Excel has done is divide 32 by 939. For E, it's 648 divided by 939, and so on. So in each case, I've used this first equation here. The probability of event A is the number of occurrences of A divided by a total number of occurrences. Okay, so far it's not that difficult. Alright, so the first question is, draw a single marble. What is the probability that has the letter G on it? So I've already computed this. It wants it rounded off to 3 decimal places. So 0.034. Okay. The next is about the probability of a marble with the letter A on it. So again, I've computed, Excel has done this for me. So that's fairly straightforward. Just cut and paste. Okay, but in each case I'm using that exact equation that I gave you, that I showed you. Okay, so finally it's F. And D. Alright, so that wasn't very difficult at all. So this is a little bit more difficult, but again, it's very easy. What is the probability that the marble you draw has the letters D or F on it? So as you know from the second law of probability, the probability of event A or B is equal to the probability of event A plus probability of event B. And the probability of all events, once added up, should add up to 1. Okay, so again, because I've already computed all these, what I'm going to do is add up the probabilities of the letters D and F in this case. So it's equal to the probability of event D plus the probability of event F. Okay, now the only thing is, even though you've added up the probability, or you've computed probabilities and rounded off to 3 decimal places, and Mathematical told you that's correct, in subsequent computations you should still not use the rounded off version, because that will be computed as wrong. Right now, Mathematica isn't adding the shorter versions or the rounded off versions to get the final solution. It's still using 10 digits to the write a decimal to get these answers, even though it's asking me to round off to 3 decimal places. Okay, so make sure you still use the longer version of the probabilities, the non-rounded off versions. Otherwise, Mathematica will count that as an error. Okay, what's the probability that the marble has the letters A or E or D? Okay, same question. Okay, it's just probability of A plus the probability of E plus the probability of D. Okay, round off to 3 decimal places. What's the probability that has the letters D or E or A or G on it? Okay, D, E, A, or G. You could just you could add them all up. So D plus E plus A plus G. Okay, or you could just say what's 1 minus the probability of F, since as the second law tells you, all probabilities should add up to 1, and in this case we're asked for the probability of 4 out of 5 events. Okay, suppose we pick 4 marbles in a row, each time replacing the marble and thoroughly shaking the jar. So in this case there is replacement. What is the probability that the first marble has the letter E on it, and it just goes on. So basically all it's asking you is to compute the probability of this sequence, given that each time a marble is drawn, it's thrown back into the jar and the jar is shaken, so the overall number of marbles isn't affected, and the probability of any subsequent event isn't affected by drawing a single marble. So if you look at the laws of probability of A and B is equal to the probability of A times the probability of B, given that A has occurred. When there's replacement, it will just be the probability of A times the probability of B. Okay, so for this sequence of events, E, A, E, F, simply take E, multiply by A, multiply by E, multiply by F. Okay, don't forget you're asked to round off to 6 digits to write a decimal. Okay, suppose we pick 3 marbles in a row without replacing the marble we just picked. Okay, so in this case the events aren't independent, so you have to keep that in mind. What is the probability that the first marble has the letter F, the second has G, and the third has G? Okay, so again it's a sequence, but the marbles aren't returned to the jar. Okay, so in the numerator, first we're picking F, so there are 89 marbles, then G, that's 32 marbles, and then finally another G, and there's only 31 left after we've already drawn one. So we start out with 939 marbles, and then we have 938, and finally we have 937 because there's no replacement. Okay, and again round off to 6 decimal places. Okay, again you pick 4 marbles in a row, each time replacing the marble. Okay, that's good. What is the probability that exactly one of the 4 marbles has the letter E on it, and 3 of the marbles have the letter F on them? Okay, so in this case you could sort of write out all the different ways in which you could have 1 E and 3 Fs in a sequence of 4 or in 4 draws, or what you could do, because this event can be expressed in a binary fashion, so F or E, what you could do is use the first portion of the binomial equation, where n is the total number of draws, in this case 4. Y is, you could pick one or the other event. I'll pick F to be Y, so the number of successes. So F in this case will be 3, and then I can figure out how many sequences will satisfy that condition. So I've just done that here. This is the first part of the factorial equation. It's the exact same equation you see here. Okay, n is 4, success is 3. How many different sequences can we create from that? 4. Okay, so what I'm going to do is compute the probability of one such sequence, and there's replacement, so it's a little easier. 3 of the marbles have the letter F, and 1 has E. Okay, so it's probability of F multiplied by another F, and by E. And don't forget that there are 4 ways to get this, so I multiply the probability of one such sequence by the total number of ways in which we could have that sequence, which is 4. Okay, and round off to 6 decimal places. Alright, now the same question, except there is no replacement. What's the probability that exactly one of the marbles has the letter G on it and 3 of them have the letter D? Okay, again, I could write them all out or use this to figure it out. I have 4 draws. I'm drawing 4 marbles. There are 2 possible scenarios. I'll say that drawing a D is a success. So, I mean, it doesn't really matter in terms of the final number of sequences. Okay, so I have 3 successes and 1 failure. It'll still be 4. Okay, but the only difference in this case is that the probability of a single sequence is a little trickier to compute. Okay, so one of the marbles has G, or is G, or has the letter G on it, so we have 32 G's, and the rest of them have the letter D. So times 122 D's. After you've picked one, there's only 121 left, and after you pick that one, there's only 120 left, and you divide that by 939 times 938 times 937 times 936. Oops. Okay, and that's the probability you're left with. Round off to 6 decimal places.